We're going to look at page 207, number 38. So it shows a picture on the page if you have to turn to it and look at it. And it says, town's planning a playground. It wants to fence in a rectangle. So we have this picture of a rectangle. But it basically only needs 3 pieces of fence because there is already an existing wall here. So the fence will just be the other portion. What is the greatest area it can fence using 100 feet? And they actually gave you a hint in the marking because you know if you're using 100 feet and you call this the length, and this the width, you would basically need the length plus the other length plus the width to equal 100. And they already labeled that on there for you. These two can combine together as 2 lengths. And they label on the diagram that the width is equal to 100 minus 2L. So you have this labeling already instead of width as 100 minus 2L. The reason you'd want that is that it's a little nicer to have every measurement in terms of the same variable instead of to keep bringing in new variables if you don't know what they represent. So our goal is to maximize area. So think about how you find area of a rectangle. You multiply length times width, which in our case is the length times the 100 minus 2 length. So our area equation is this distributed to each of these. If we wrote that in standard form, we would write the negative 2L squared first plus the 100L. Now, we can basically take this and put this into a calculator. And when you do, you get a graph that looks like this. And our goal was to find the maximum area, which would be at the vertex. So with or without a graphing calculator, I can find that vertex. Remember, we find the x-coordinate of the vertex when it's in standard form by doing negative b over 2a, which would give us 25. And then if we plugged 25 back into the equation, we could go ahead and get the y value that goes with that x value for the vertex. So we would get 1,250. So the vertex has coordinates 25, 1,250, where 25 is the L, because that was like our x coordinate of the equation, and 1,250 is like the A, and that's at the top of this parabola. That's the maximum value. So returning to the question, it asks what's the greatest area of fencing. That's the A part of the vertex. So the greatest area would be 1,250 feet squared.